Okay, welcome back everyone to Grockit OG TV. My name's Jim Jacobson. That's me right here, over in the corner. This is the GMAT edition, like it says right there. We're doing the 12th edition of the official guide to the test, question by question, cover to cover, page by page, doing every question that they have, going through the answers and giving you some explanations, and you get to watch as we go through them, giving you tips and tricks and strategies and just showing you how tutors would go through the questions. So when we left off last time, I guess I don't really need to leave my smiling face on there. Let's get rid of that and get to the real stuff. When we left off last time, we were on page 161, question number 64. Okay, and so we have in our answer choices, they're all dollars. We have 10,350. We have 10,395. We have 10,500. We have 11,500. And $12,705. Okay, so Lucy invested $10,000 in a new mutual fund account exactly 3 years ago. The value of the account increased by 10% during the first year, increased by 5% during the second year, and decreased by 10% during the third year. What is the value of the account today? So we know that she started out with $10,000. We know that it then went up 10%. It went up 5% after that, the year after that, year 2, and then went down 10%, as did many people's accounts a few years ago. So we simply need to follow this question step by step and just compute each of the steps along the way. So if it went up 10% and it was at 10,000, remember that 10% of 10,000, you can just move the decimal point over 1. That's it goes up $1,000. So we add $1,000 to that, and we get $11,000. That's a dollar sign. Take my word for it. Then it goes up 5%. So you can, of course, multiply times 0.05 with big numbers with lots of zeros. It may be easier to say, well, let's just take 10% of it, which would be 1,100, then take half of that. Half of 10% is 5%, so half of 1,100 is $550. So her new total is now 11,550. That's a comma. And then it needs to go down 10%. Once again, moving the decimal point over 1 to get our 10%, that's $1,155. For this one, I personally am not able to do the math in my head, so we need to do it out separately. 1,155 minus 1, 1. Did I do that right? 1, 1, 5. Yes, I did. 1,155. So 4, 5, 4, 9, and we can already see how this is going to end up. Only one of the answer choices ends in 95. But let's just pretend like it wasn't going to come out that way. It does come out to be $10,395 as we expected. So it's minus 1155 and $10,395. The other answer choices, I guess, are just counting on computational errors or skipping a step. You could have also just multiplied the whole thing out. So starting out with 10,000 times a 10% increase. So that's 110% of what it used to be. Then multiplying that times a 5% increase. And then multiplying that times a 10% decrease, where it would be 90% of what it was. If that type of math comes more easily to you than what I just did, then you should definitely do that. I personally would have found this to be too much trouble, but your mileage may vary as always. So it still ends up coming out to be the exact same number, however you do the problem. Okay, so that's enough of number 64. Let's move on to number 65. So still page 161, number 65. 10, 11, 12, 13, 14. 10, 11, 12, 13, 14. So a certain fruit stand sold apples for 70 cents each and bananas for 50 cents each. If a customer purchased both apples and bananas from the stand for a total of $6.30, what total number of apples and bananas did the customer purchase? So apples are 70, give me the decimal point, 70 cents each. Bananas are 50 cents each. And the total of, well, really it's 0.7 times the number of apples plus 0.5 times the number of bananas equals $6.30. Computer does not want me to give you decimal points. Okay. There are some easier ways to go about this one. You can just do this as two equations with two variables, or by plugging in numbers from things. Personally, one way to approach this is that things ending in 30 cents with multiples of 7 and 5 make this a rather easier problem. That is to say, no matter how many bananas you have, multiples of 5 either end in 0 or in 5. So, if there's, just as an example, bananas. So if there's 2, 3, 4, 5, 6. So if there's one banana, whatever the cost of the bananas is, it's going to end in 50 cents. If it's 2 bananas, it's $1. 1.50. Yikes. $2. 2.50. Dang it. Give me $3. So this is a 50 here on number 3. So the multiples of the bananas really only end up in a 5 or a 0. So we have to figure out a way that the total number can end up in a 30. And so obviously the key is the apples, which are multiples of 7. So, and keep in mind, of course, that if we're adding one of the even multiples of 5, the even number of bananas, to our number of apples, we're not actually going to be changing the tenths of a dollar digit at all. So really what we're after is what multiple of 7, because it's going to be a multiple of 7, plus an odd multiple of bananas, something that ends in a 5, is going to give us a digit that ends in 3, like this. Let me give you some examples. Let's actually put the apples down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't have to go up to 10 because if we actually sold 10 apples, the total would be $7, which is actually over the $6.30 that we're after, so that can't possibly be right. If we sold 1 apple, it's 70 cents. 2, we're just doing multiples of 7 here. 2, it's $1.40. 3, $2.10. 2.80. 3.50. 4.20. 4.90. 5.60 and 6.30. So of course the first thing we might jump on is nine apples sold at 70 cents each actually gives us 6.30, but the problem actually states that the customer did purchase both apples and bananas. So since this option here allows for only apples and no bananas, that can't possibly be it. What we're then after is which ones of these answer choices have a tens digit, a dimes digit, a tenths of a dollar digit, that when we add 5 to it, we end up with 30 cents as the remainder. Only one of these, when we add a 5 to it, would we get a 3. 280. 280 plus some multiple of 5 will end up with a 30-cent remainder. So then the question is, what is the total number? So if the customer purchased 280 worth of apples, we just subtract 280 from 630. I don't know why the computer doesn't like decimal points today. The customer purchased 350 worth of apples, or excuse me, bananas. That was actually number 7 on the list, didn't get that far. So that means there are 7 bananas and 4 apples for a total of 11 pieces of fruit purchased. Choice B. Sorry for perhaps making that a little bit longer than it needed to be. I just needed to explain why I was doing what I was doing. Obviously, on the real GMAT, it wouldn't have taken you nearly as long to do the same thing as I did because you wouldn't be explaining it to anybody. I suspect that the proctors would kick you out if you sat there explaining how to do every problem you were doing out loud. So don't do that. So page 161, question number 66. We have A, B, C, D, E, 16 to 15, 9 to 5, 5 to 16, 5 to 4, and then 4 to 5. Okay. At a certain school, the ratio of the number of second graders to the number of fourth graders is 8 to 5, and the ratio of the number of first graders to the number of second graders is 3 to 4. If the ratio of the number of third graders to the number of fourth graders is 3 to 2, what is the ratio of the number of first graders to the number of third graders? Right. Well, that's a lot of ratios to keep track of, and they're clearly not all in the same terms. It's also clear to us that we're going to have to put them in similar terms in order to solve this one. So we have these different grade levels. We have first grade, we have second grade, we have third grade, and we have fourth grade. Part of Grockit's commitment to ordinal numbers is writing them out. It's not really in the mission statement, but I still like to do it anyway. Okay, so that's our heading here. We know that initially the ratio of second graders to the number of fourth graders is 8 to 5. So we can just write that right there, 8 to 5. We know that the ratio of first graders to the number of second graders is 3 to 4. And the ratio of third graders to fourth graders is 3 to 2. And we need to know the ratio of first graders to the number of third graders. So really there's no particular order that we need to do these things in. In order to compare ratios, they need to have the same basis. This is similar to, as if each of these were a fraction. So second to fourth graders is 8 to 5, and first to second graders is 3 to 4. Except in this case, these are the second graders, and these are the second graders. So in order to make them comparable, we would need to double this fraction so that we have eighths. Anyway, we're not going to do it by fractions. We're going to leave it as ratios just to keep things straight. So if we were to try and come up with the ratio of first to second to fourth graders, clearly the key is this element here. We have, for every 8 second graders, we have 5 fourth graders. If we can convert this so that there are 8 second graders, we can have a comparable ratio. So really we just need to double the whole ratio. 3 to 4 is the same thing as 6 to 8. So we now have 6 first graders to every 8 second graders to every 5 fourth graders. However, we need first to third, so this is the one that's still missing here. We need to have these in the same ratio, and the common multiple of 2 and 5 is 10. So we actually are going to have to, in order to get this guy to 10, we need to multiply all of these by the same number, namely by 2. So these have to be times 2 to get tens, or tenths, however you want to think about it. And then these have to be multiplied times 5. So that this will be, so that the number of fourth graders here will be expressed as tens as well. So to multiply these have to be times 5 to do the same thing. So the new ratio then, multiply all these times 2, the first graders, we have 12 first graders to 16 second graders. Remember, we had to multiply the third graders by 5 to 15 third graders to 10 fourth graders. So this is the final ratio of all of the different grades, 12 to 16 to 15 to 10, now that they all have the same common multiples. And so the final question, just make sure we answer the correct thing. The ratio of the number of first graders to the number of third graders, that's this one to this one, that can be expressed as a fraction, 12 to 15, or as 12 to 15. Both are divisible by 3. 12 is 4 times 3, and 15 is 5 times 3. So the ratio is 4 to 5, which is answer choice E over here. This one obviously is the trap answer. This is the reverse of the ratio we were after. And then these other ones are other misunderstandings. 16 to 15 is second to third graders, as opposed to first to third graders. So if you solve for the wrong thing, that gets you into trouble on the GMAT. Okay, moving on. Choice E was correct. 161, number 67. We have 0.15, 0. Come on, please. 0.20, 0, no, 0.25, 0.30, and 0.33. So 2 integers will be randomly selected from the sets above, 1 integer from set A and 1 integer from set B. What is the probability that the sum of the 2 integers will equal 9? Let's get those sets on the board. A equals the following, 2, 3, 4, 5, 2, 3, 4, 5. B, slightly larger set, 4, 5, 6, 7, 8. Okay. And we need how many different ways numbers chosen randomly can get to 9. Keep in mind that probability equals the number of desired outcomes, the number of things you're trying to figure out, not necessarily that you want to happen, but the number that you're trying to figure out of the total number of outcomes. All the things that could happen in the situation that you're after. Let's figure out the total outcomes first. So for every number we choose from set A, there are going to be 5 different pairs of numbers. So 2 plus 4, 2 plus 5, 2 plus 6, 2 plus 7, 2 plus 8. So for every number in A, there are 5 different choices in B. So the total number of probabilities is the number in A times the number in B. It's supposed to be a B. So in this case, the number of options in A is 4. The number in B is 5. There are 20 different possibilities, 20 different pairs of numbers that we can choose when we choose one from A and one from B. Now, how many of these add up to be 9? 2 can only be added to 7 to get 9. 3 can only be added to 6. This 4 can only be added to 5, and this 5 can only be added to 4. 8 can't be added to any of the numbers in A to get us 9, so there are only 4 different pairs of numbers that add up to 9, because each of them there's only one. If there had been 2 4s or 2 5s, if there had been 2 of any of these numbers or 2 of any of these numbers in the sets, that would have increased the number of possibilities. But there's only one of each, so they only have one complement there that can add up to 9. So 4 possible outcomes out of 20 total outcomes. 4/20ths is the same thing as 1/5. Unfortunately, 1/5 does not appear as any of the answer choices. However, 1/5 is the same as 2/10ths. So 4/20ths, 1/5, same thing as 2/10ths, which is 0.2. Probability can be expressed as a fraction or as a decimal, ranging from 0 to 1 inclusive. So, choice B, correct answer. Number 68 on 161. We have 155, 96, 80, 48, and 24. So at a certain instant in time, the number of cars, n, traveling on a portion of a certain highway can be estimated by the formula, and we'll write that down after we finish the question, where L is the number of lanes in the same direction, D is the length of the portion of the highway in feet, and S is the average speed of the cars in miles per hour. Based on the formula, what is the estimated number of cars traveling on a 1/2 mile portion of the highway if the highway has 2 lanes in the same direction, and the average speed of the cars is 40 miles per hour? And then they go ahead and tell us that there's 5,280 feet in 1 mile. Thank you, GMAT. So we have our formula. Let's get that towards the top because we're going to be filling things in as we go. 20 times L times D over 600 plus that speed squared. So n is what we're trying to figure out. That's the estimated number of cars. So n is going to remain our variable. However, we are given data on every single one of these other variables in the rest of the question. So n equals 220. Capital L is the number of lanes in the same direction. We find out that that's 2. The D is the length of the portion of the highway in feet. So it is 5,280, or actually half of 1 of 5,280. So let's just leave that fraction in there because these numbers are going to get big if we don't. 5,280. All of that. So keeping track, this guy here is the D. It doesn't really matter ultimately. But just making sure that we've included all the variables from the question, from the formula, into our thing here. And the speed is 40 miles per hour. 40 squared. We can do a little math here. 2 times 1/2, these two guys cancel out. And we can figure out the next step. That's going to be 20 times 5,280 times 600 plus, and then 40 squared ends up being 1,600. 4 times 4 is 16, and then you have to add the two zeros on for the two decimal places that we missed. That in turn, we're going to leave those multiplications out there, so 20 times 5,280 over 2,200. Whenever possible, look for ways to save yourself doing massive amounts of math. Multiplying 5,280 times 20 is going to give you a very large number, larger than you perhaps want to deal with, and then dividing by 2,200 also. We can notice, though, that this number ends in a power of 10, this is a power of 10, and then this is a power of 10. So we can actually divide by 10 twice. We divide by 10 twice, we get rid of these two zeros and these two zeros. So then we're left with 2 times 528 over 22, and then we can divide the numerator and the denominator by 2. We end up with 528 divided by 11. Now, of course, they didn't give us that in the answer choices, so we do actually need to do the long division. 528 divided by 11. It doesn't go in 5 times because that would be 55, so it starts with a 4. We actually don't have to go any further. Only one answer choice begins with a 4. Whenever possible, save yourself a little bit of time. But if we were to do it out, 4 times 11 is 44. 52 minus 44 is 8. 88, so then clearly this would be the rest of the problem. But 48, just the tens digit of our quotient ends up being enough to identify the correct answer. Had all of these started with a 4, we would have had to do the work the rest of the way. So choice D is the correct answer, and we are ready to move on to the next page. Which ends up being a data interpretation problem, or data, depending on how you learned it. Page 162, number 69. All right, so we have 250,000, 280,000, 310,000, 325, and 340. Okay. As tempting as it is to redraw the whole diagram, I don't think I'm going to have to on this one. So according to the chart shown, which of the following is closest to the median annual number of shipments of manufactured homes in the United States for the years from 1990 to 2000 inclusive? The inclusive bit just means we have to include the two endpoints in our discussion, both the 1990 and the 2000. And median, remember, median is one of those issues with sets. The median equals the middle number. So if you have median, if you have an odd number of numbers, it equals the middle number. And if you have an even number of numbers in your set, it's the average of the two middle. So in this particular case, 1990 to 2000 gives us 11 different numbers. You can either count them or say that 1990 to 2000 would be 11 numbers, because 1991 to 2000 would be 10. 1 to 10 is 10, 0 to 10 is 11. So we have 11 numbers in our set, which means that the exact middle number is our median. They did not have the kindness to make a graph where the numbers appear in ascending order, where we could just pick out the middle one. That's probably okay because we're smart enough to figure this out. One of the things to notice whenever you get a problem like this, and there's no guarantee you would get one like this on the GMAT, but if you do, look for any trends in the numbers. We notice that there is a line, the line at 300,000 number of, let's say, number of shipments. So number of shipments 300,000. We have some of the bars on the bar graph above 300,000 and some below. In fact, we have the first 4 lines on that graph, the 1990, 1991, 1992, and 1993. Those are below, as is the 2000. So below 300,000, and then we have some above 300,000. Sorry for the sloppy writing. This tablet isn't cooperating very much. So in the below 300,000 category, we have 5 numbers. The first 4 and then the last one. In the category above 300,000, we have 1994 through 1999, which is a total of 6 numbers. Now remember, we're looking for the middle number. If the lowest 5 are below 300,000, then the middle number must be in the section above 500 or above 300,000. Because remember, the median has, when you have an odd number of numbers, it has the same number of numbers above it and below it. So because the above 300,000 has more than the number below 300,000, we know that our median is in this one. Not only do we know that, we know that by definition it has to be the lowest of those above 300,000. Because remember, the median has 5 numbers higher and 5 numbers lower when you have a set of 11 numbers. So basically, we just need to look at the chart and find the lowest one above 300,000. I look at the chart, I see it as 1994, which looks like it's just over 300,000. The only one, the lowest one in the answer choice is just over 300,000 is choice C, 310,000. Even if we had just gotten to the point where we realized that more of the numbers were, that one more than half of the numbers were above 300,000, we could have crossed off these 2 guys knowing that the median was in the above 300,000. But then just realizing that the median has to be the middle one and half the numbers need to be higher, we cross off those 2 because it needs to be the lowest of those above 300,000. We are awesome. No, don't have only one eye. There we go. Okay, that's number 69. Choice C is the correct answer. On to number 70, still on page 162. So A is 2/3, B is 5/3, C is 7/3, D is 1, and E is 4. So if y times the quantity 3x minus 5 quantity over 2 equals y, and y does not equal 0, then x equals something. Let's get that up here. So y times 3x minus 5 over 2, that equals y, and y does not equal 0. What is x? Notice immediately that this y does not equal 0. Whenever they give you one of these, where they go out of their way to tell you that something does not equal 0, that's a hint. It doesn't always work as a hint, but it can function as a hint. Basically, it means that they don't want you to be able to divide by 0 or be expected to divide by 0 and then sue them for having a wrong test. So in this particular case, we do want to divide by y in this case, because we have a y on both sides of the equation. So right now we start out with one equation with 2 variables, but one of the variables is about to go away. So divide both sides by y, we end up with just 3x minus 5 over 2. Y divided by y equals 1. No more y. Bye-bye y. Multiply by both sides times 2, we get 3x minus 5 equals 2. Add 5 to both sides, 3x equals 7. Divide both sides by 3, x equals 7/3. Choice C. I think the trick in this one is just realizing that you can divide by y right away to get rid of the second variable so that you are left with a one variable, one equation problem. Otherwise, this would have been really hard, if not impossible. Anyway, choice C, correct answer. 162, number 71. All right, so we have some ranges here. I'm going to skip the word and because I'm lazy and because you have the book in front of you, so you know that this is what's going on. So each of these is a range of values. Pretend that these are something meaningful that tells you it's a range. I should have just written and, I'm sorry. Anyway, if x plus 5 is greater than 2 and x minus 3 is less than 7, the value of x must be between which of the following pairs of numbers? So this one tests your comfort level with inequalities, and the thing to remember about inequalities is that there's not that much different about them from equations. You can treat them like equations in most respects. You can add and subtract from both sides of an inequality. You can also multiply and divide. It's only when you multiply or divide by a negative number that you need to reverse the direction of the sign. If you're dividing by a variable and you don't know whether that variable is positive or negative, that's when inequalities become trouble. So we're given two of them. We're given x plus 5 is greater than 2 and x minus 3 is less than 7. In both cases, we can simply solve for x, and these are arithmetic issues here. We can subtract 5 from both sides of the first one. So we're subtracting 5. We get x is greater than negative 3. And we add 3 to both sides of the other one. X is less than 10. So x is, if we put it all in one statement, less than 10 and greater than negative 3, which looks a lot, so much like that it would pass as correct to the point where it is correct. Choice A, negative 3 and 10. The obvious trap here is this one. If you somehow, I don't know, I guess you wouldn't really get it by adding 5 to both sides. I guess if you forget that you can have a negative number here, you might choose it as being between 3 and 10. It's meant to catch a careless mistake, which we didn't make, but could happen. It's only care and attention that prevent those. Anyway, choice A, correct. So 162, number 72. We have 20, 24, 36, 48, and 96. So a gym class can be divided into 8 teams with an equal number of players on each team, or into 12 teams with an equal number of players on each team. What is the lowest possible number of students in the class? So we have they have some number of students in the class that can either be divided evenly by 8 or evenly by 12. So of course you can just do this kind of brute force ways, or just you can do it kind of mathematical insight, or doing the proper method for solving any problem like this. The straightforward insight is to look at this and say, well, we want the least common multiple of 8 and 12. If you're familiar enough with kind of that lower level of multiplication, the least common multiple of 8 and 12 is 24, which is the correct answer. But it could have been actually that this had much more complicated numbers in it, numbers that you were less familiar with. And basically, when you have least common multiple questions, you need to include all the factors of each of the numbers that are going in there. So 8 has as its factors 2 times 2 times 2. 12 has 2 times 2 times 3. Okay, so the least common multiple of these will have all of the factors of these. Now, if you have 2 times 2 times 2 among the factors of your thing, you automatically have 2 2's. If you have 3 2's, 2 to the third, you automatically have 2 squared among the factors. So we don't even have to count this. But the 8 does not account for the 3. The 3 in the exponent doesn't count. So we need the 3. So the least common multiple of 8 and 12 is 2 to the third times 3, which is the same thing as 8, times 3, which we've already established is 24. But this same method would work if you had come up with, 528 and 1246 or something ridiculous. You could factor all of these out, figure out what common factors they have, and then only add up the ones, or only multiply the ones that they do not share, so that every factor is used at least once. Choice B, correct answer. On to 73 on 162. Okay, R less than S less than T, R less than T less than S, S less than T less than R, S R T, T R S. What fun. Okay. So if R equals 0.345, S equals 0.345 quantity squared, and T equals the square root of 0.345, which of the following is the correct ordering of R, S, and T? So let's just get those down. We have R equals 0.345. S equals that quantity squared, and T equals the positive square root of that. So we can see that all of them use the same original number, which is a fraction between 0 and 1, or a decimal between 0 and 1. The thing to remember that's special about fractions between 0 and 1 is that as you raise them to higher powers, they become smaller. So, for example, R, if we were to cube R, it becomes increasingly smaller. As the exponent gets bigger, the number gets smaller. As the exponent gets smaller, the number gets bigger. So, with that in mind, we can actually put all of these in terms of exponents. So let's just say that x equals 0.345, because all three of these use that. So R equals x to the first power. S equals x to the second power. And T equals x to the 1/2 power, because remember, square roots are, or roots in general, are fractional, are expressed as fractional exponents. So, remembering then that as the exponents get bigger, the number gets smaller, and as the exponents get smaller, the numbers get bigger, the ordering of the exponents in terms of smallest to biggest, x squared with the biggest exponent is the smallest number. The next smallest is x to the first, and then the one with the smallest exponent is the biggest number, x to the 1/2. Putting those in back in our original terms, x squared was s, x to the first was r, and x to the 1/2 was t. So that leaves us with choice D as the correct answer. Ta-da. Okay, let's move on to number 75. "19, 17, 16, 14, 13. So at least 2/3 of the 40, oh no, I skipped a problem. Haha, I'm sorry. Oh, good thing I caught that. Number 74, page 162. I guess there's proof in case you were wondering whether this was recorded live. There it is, recorded live. Error. At least I didn't get too far. Okay, so this one's 1/6 n. We have 5/12 n. We have 1/2 n. We have 8/15 n. And then 11/12 n. Okay, a total of n trucks and cars are parked in a lot. If the number of cars is 1/4 the number of trucks and 2/3 the trucks are pickups, how many pickups in terms of n are parked in the lot? So we can treat this as two equations and two variables. We have cars and trucks. C equals cars, T equals trucks. That's a K. C plus T equals N. Cars plus trucks equals N. And we also know that the number of cars is 1/4 the number of trucks. So the ratio of cars to trucks, C over T equals 1/4. For every one car, there are 4 trucks. We can then also multiply that out and solve for C and T respectively. So we want T equals 4C, if we were to cross multiply, and C equals 1/4 T. I'll put a comma there to show that those are our two equations. These three guys are all the same thing, just expressed in different ways. From there, because we need to figure all of this out in terms of T, because we have to figure out the 2/3 the number of trucks are pickup trucks. So we need the whole expression in terms of T. So we're going to use this guy here, and we want to replace C with something else. So we end up with C is 1/4 T plus T equals N, which is the same thing as, just to spell it out, 1/4 T plus 4/4 T equals N. So that's 5/4 T equals N. So the number of vehicles in the lot is 5/4 the number of trucks. So just to convert this in the other direction, we want this to be the number of trucks in the lot. How many trucks are in the lot? If 5/4 of the vehicles in the lot, if 5/4 the number of trucks in the lot is the number of vehicles, we can just solve for T. T equals 4/5 N. So 4 out of 5 vehicles in the lot are trucks. And 2/3 of those are pickups. So we are just going to multiply 2/3 times 4/5 N. Multiply across, we end up with 8/15 N, which is answer choice D, and it is correct. That was the two equations and two variables method. There was a faster way. Whenever you get ratios, one of the things you should do in your head is just figure out what the total number is. Way back when we figured out that the ratio of cars to trucks is 1/4, so if, cars to trucks is the ratio of 1/4, then the number of vehicles in the lot needs to be a multiple of 5. 1 plus 4 is 5. So therefore, the number of, for every the number of trucks in the lot, or the trucks versus the total number of cars in the lot, is 4/5. The number of cars in the lot, or the ratio of cars in the lot to number of vehicles in the lot is 1:5. The ratio of trucks in the lot to vehicles in the lot is 4:5. So just by looking at this and doing 1 plus 4 equals 5, we've already skipped that step that we got to at the end there, that the trucks are 4/5 of the number of cars in the lot. And then we just needed 2/3 of that. And that gives us the 8/15. So there won't always be that speedy step there, but in terms of things to do every time you're given a ratio, have at the back of your mind, hey, you know, if I'm given this relative ratio, I already know not the total number, but at least what the total number is a multiple of by adding together all of the elements of the ratio. Okay, let's do another one. Let's do the one that I started to do before I so rudely interrupted myself. So the last one on page 162 is 75. So, as I did last time, we have 19, 17, 16, 14, and 13. All right. At least 2/3 of the 40 members of a committee must vote in favor of a resolution for it to pass. What is the greatest number of members who could vote against the resolution and still have it pass? Right. So we have a 40-member committee. So at least 2/3 must vote in favor. So 2/3 or more, and they win. So in order for it to fail, which is what they're asking, what is the greatest number who could vote against the resolution and still have it pass? So if 2/3 will carry the motion, 1/3 on its own, voting against, it still passes. Because if they actually, it's 2/3 or more, that's what the at least 2/3 expression means. If they get exactly 2/3, which of course they can't with a 40-person committee, but if they get 2/3, it passes. So if exactly 1/3 votes against, it still passes. If more than 1/3 votes against it, it fails. What does 1/3 of it equal? So 1/3 of 40 is, so we just, 40 divided by 3 ends up being 13 1/3. So 1/3 equals 13 1/3 people. You don't have 1/3 people on there. So basically, if 13 people vote for something, that's less than the third voting against it, which means they get more than 2/3 voting for it, it passes. If 14 people vote against something, which is more than the 1/3, then it fails. So the largest number of whole people, because only whole people can vote, the largest number of whole people who can vote for something and still have it pass is 13. Choice E. Yeah. And I think we have time for one more. I can fit one more in here. So on to page 163, new page dawns on us, number 76. We have $900, $720, $675, $450, and $225. So in the Johnsons' monthly budget, the dollar amounts allocated to household expenses, food, and miscellaneous items are in the ratio 5 to 2 to 1, respectively. If the total amount allocated to these three categories is $1,800, what is the amount allocated to food? So, as I was just talking about 2 questions ago, 5 to 2 to 1. One of the things one of the things I always do is just figure out what's all of this going to be out of. So 5 plus 2 plus 1 equals 8. So whatever this ends up being, it's going to be divided 8 ways and 8 shares total, with then household expenses getting 5 shares, food getting 2 shares, and miscellaneous item getting 1 share. The total budget was $1,800, and then we basically need to divide that 8 ways to figure out what 1 share ends up being. So 8 times 2, 16, 20, 2, 16, 40, 225. So 1 share equals $225. Trap answer, of course, is this. That's 1 share, which is the amount for miscellaneous expenses. But we actually need to know the amount for food, which is this middle one. 2 times that share of 225 equals 450, which is choice D. Do note the trap answer 675. This one is food plus the miscellaneous expenses. So that's another one of those traps. I don't know where they get 900. I didn't figure out where they came up with all of these, but those two jumped out at me as the trap answers. So choice D is correct. That's as good a place to stop as any. We can pick up next time, pick up tomorrow, and we are going to start with number 77 on page 163. My name's Jim Jacobson. That's me up here. Happy again. And you've been watching Grockit's OGTV GMAT edition. We're going through the 12th edition of the Guide to the Test, page by page, question by question. And yeah, I don't know. That's really all I have to say about it. See you next time.